this video, I will try to go over the algorithm that finds the median of two sorted arrays. So why am I going over this problem? The first reason is that it is an excellent and non-trivial use of the divide and conquer technique. Also, many people, they have some idea of how to solve this problem, but they could not pinpoint the exact math behind it. And also there are several online solutions that are poorly explained or not very intuitive or too complicated. Alright, so in this video I will just try to give an intuitive but hopefully precise solution and explanation to this problem. Okay, so first let me state the problem. If we have n ordered elements, x1, x2 up to xn, okay, then the median of these elements is defined to be the middle element, which is x of n plus 1 divided by 2 if n is odd. If n is even, there is no middle element, so a popular convention is to take the average of the two middle elements, which is x of n over 2 plus x of n over 2 plus 1. Okay. The problem asks that we are given two sorted arrays, A of length n and B of length m. Okay, I will use the indexing that starts from 1 in this video. And the problem asks that we find the median of the elements of these two arrays in log of minimum of n and m, 10. Okay, this is rather tricky. Okay, so how do we go about this? Let's make some very simple observations, almost self-evident. The median must be of n elements must be larger and smaller than exactly n over 2 elements if n is even. If n is odd, we just replace n over 2 with the floor function of n over 2. And so based on, okay, so n is the number of elements. Okay. Now, based on the first observation, we deduce the second one, which is that the median of n elements cannot be larger or smaller than n over 2 rounded up plus 1 elements or more. Okay. The second observation is a direct consequence of the first observation. These two are pretty obvious to check. If you are not sure, feel free to stop the video and check it. Alright, so let's look at the first simple case. If the median of A is equal to the median of B, alright, then it is easy to see that, this median is indeed the median of A and B combined, because it will be smaller than half of the total number of elements and larger than half the number of elements when you combine the arrays. Of course, we don't do that in the algorithm. Okay, so this case is trivial. Now, if the median of A is strictly larger than the median of B, then the median of A and B cannot be in these two intervals. It cannot be in A of n over 2 rounded up plus 3 up to n. And it cannot be in another interval, which is b1 up to b of m over 2 rounded down minus 3. The reason I'm choosing the constant 3 here is for the math to be simpler. There's nothing really unique about it. Okay, so for example, in the example in this slide, right? So the median of A is 7, which is larger than the median of B, which is 5, right? So this interval here on the, slightly, roughly the right half of A cannot contain the overall median because these elements are larger than half of the elements of A, a bit more than half of the elements of A, and half of the elements of B, right? So it is strictly larger than, it is larger than too many elements that a median is allowed to. Let's go back to our second observation above. Okay, so similarly, all elements in this interval correspond to this part, okay, is going to be smaller than more than half of the elements in B and half of the elements in A. Okay, so it's too small to be, they are too small to be the elements, the medium of A and B. Okay, so you can easily throw away these elements. Now, but you need to be careful when you do that. Okay, so before we do that, if you really want a mathematical proofs, this is one. Okay, so you can pause the video and check the math. I'm not going to spell it out, but this is a rigorous proof. Now, okay, so I said we can throw away, these elements, but the arrays may have different size. Okay, so you need to look into these two intervals and look at which interval contains more elements. Okay, so let K be the minimum of elements, the minimum between, the minimum, the smaller of the size of this interval and the size of this interval. Okay, so again, let me repeat this. Consider the size of this interval, an over 2 plus 3 up to an, and the size of this interval b1 up to bm over 2 minus 3. You look at these two intervals, so they would have two, so each may have different size. They may have different sizes. Okay, so you take the smaller of the two in terms of sizes. Okay, now you throw away k element, leftmost element of B, okay, and k elements, k rightmost element of A. Okay, so why do we do that? When we do this, okay, we throw away k elements that are larger than the median, and these elements cannot be, these elements cannot be the median. And okay, so when we throw the k rightmost elements of A, we throw away k elements that are larger than the median. When we throw away the k leftmost elements of B, we throw away k elements that are smaller than the median, and now we can recurse on the remaining elements of A and B, okay, because we didn't change the median. Okay, so the median of A and B is still the median of the remaining elements. Okay, so we do this recursively. Okay, the third case is just the opposite, when median of A is less than the median of B. You can use the same logic to come up with this statement. Okay, so you can throw away the right half of B and the left half of A. Okay, so what is the base case here? I'll just pick 4. Okay, so I will leave this as an exercise, but you can compute the median of A and B in constant time by just looking at A1 up to A4 and B of m over 2 minus 5 to b of m over 2 plus 5. Okay, so based on these constant number of elements, you can figure out the median. Okay, think about why. The case of m less than or equal to 4 is handled similarly. Okay, so what is the running time? We stopped when either array reaches length less than or equal to 4, and the algorithm runs in log of min of n and m time, because in each recursion level we shrink the smaller array by a factor roughly a half. Okay, so that's why we have such a running time. Okay, so I will stop here, and I hope you find this video useful. I will see you in another video in which I will implement this algorithm. Thank you for tuning. Bye bye.